Module 3.2 notes. Some time ago we talked about domain and range. You guys remember that?
Yes.
And then we never really used it, which was kind of unfortunate. Now we're going to use it. Domain. What's the domain?
The area,
Yeah, I know what you're talking about with that. It's kind of like the turf, isn't it?
yeah.
So the turf is left and right.
Yeah.
That's your x values. It's the x values, yeah. They're the input. Values. They're the input values of a set. They're the horizontal values. Jonathan, you have a question?
Range is y, right?
Range is the y, right. They're the outputs, or the output values of a set. That's your up and down, yep. So today we're going to learn the proper way to list these out and look at them. We need to learn a symbol. It's like an E that's sort of made like a C. It's called the element, or it's just element of. So let's say I give you a set of values, a very small set. And I go 0, 1, 2, 3, and 5, 7, 9, 11, something like that. How would we list the domain? Here's how we list the domain. Oh, you have a mark here? Yeah, when you say 0 through 3, does that include 1.5? 1.25, 0.793? Yeah. Now, in this case, we've got a discrete situation. So if it's discrete, we say x is an element of, and we use ellipses. This is for discrete, and we would just list them, 0, 1, 2, and 3. If we had the same number twice, we wouldn't list it twice. Where's your notes? No, yeah, you. Where's your notes? Where's your pencil? Uh-huh. Whoops. Okay. So this x refers to the domain, and these ellipses refer to it being discrete. Yes? Notes. I'm not making these for my good. When you guys come in and you have no pencil, you dang well better ask, do you have a pencil in the beginning?
You can borrow a pencil.
Because otherwise I'm just going to send you out to the office from here on out. Do you understand? Come get it. You're laughing, but I'm not thinking it's funny at all.
Sorry, the office likes
It's a
me.
waste of time.
No, they don't. Trust me. We talk about you all the time.
Probably do.
Don't waste my time. So the ellipses indicate that it's a discrete situation, that those are the only values in the set. How about the list of the range? Well, the range is going to be the y values, and the y elements are, in this case, 5, 7, 9, and 11. But it's a discrete again.
I'm so good at doing ellipses.
Okay. That's all right. As long as they look like they have a little whoop-dee in there, we'll all know what they are. It took me years to be able to draw them reasonably well. I still screw them up sometimes. Okay. So the y is indicating range, and the ellipses again are indicating discrete. Discrete meaning those are the only parts of the whole set. There's no like 1.5 or anything like that. It's just that's it. So now that we've learned this is for a discrete set, I'm being mean, I'm making you draw it a bunch of times, so get used to it. This is for a discrete set, but what if it's continuous? Which it oftentimes is. Very, very.
Quotation. I mean, parentheses.
It is. That's one way. Parentheses indicate continuous, but not included. What I mean by not included is the same idea as an open dot. Like a while ago, we looked at problems like this. We said, how would we graph x is greater than 5? And what we learned was that if it's greater than or less than, we use an open dot at that value, right? And then this would shade in one particular direction. So what I want you to think about is this. When you see the parenthesis, it's like an open dot at the end of some line. It's an open dot. What if it's a closed dot?
Then it's still.
It's brackets. That's correct. Yeah, it's brackets. And we can mix these. Because on some lines we might have an open dot on one end and a closed dot on the other. These can mix. But this is still a continuous idea. Included. So it's your closed dot. Something like, although not exactly like, but a similar idea to x is less than or equal to 5. So that would be a closed dot and shading everything to the left. We don't have shading on our graphs at this point, but open dot and closed dot ideas we definitely do.
What about quotation marks?
We don't have those, not for this kind of thing. Okay, give everybody a second to get caught up if you're not. So there are some special situations before we apply those. What if the line goes on forever? Plus or minus infinity is never included. You'll use infinity, but if you do, we always use parentheses. For whatever end infinity is. And one other thought that I want you to know about. An individual point is neither increasing nor decreasing. Individual point is neither increasing, I think proper English would say nor there, nor decreasing. So let's put it into use. Let's try something here. Make a simple graph here. Go about 3 in each direction, not too big. And let's say I've got a point here at -2, -2. And I've got a point here that's not really a point, it's an open circle at 1, 1. And I'm going to connect those two with a line. I think this is a simple idea. However, every year I have students fall through the cracks and not really get the idea here. Maybe because the lines aren't right on the x and the y axis, but we're looking at values. Where do the x values begin? So I used an example that I hadn't thought of before. How many people have played Fortnite or seen it played? A few of you? Probably nearly all of you? Okay. So what happens in Fortnite is the storm comes in, right? And it closes the area off that you do the battle in. And if I understand the thing right, as I'm watching my son play hours and hours of it, is that if you're stuck in that, outside of that storm zone or whatever it is, or you're in the storm, whichever it is, that if you're in there for too long, you get killed, right? Okay. Yeah, you lose health or whatever, and then you get dead. So my card is going to be like the storm, the line of the storm coming. And the line is like the players that are in the game. Okay? So as I'm coming across, when does the storm line touch the first player?
-2.
Right, at -2. And I keep coming across, when does the storm quit touching any of the players? At 1, right? That's your domain. Those are all your x values that exist in there. So for our domain, that is going to be x is an element -2 to 1. Now, around one of these numbers I need a bracket, and around another one I need a parenthesis. Which one gets the bracket and which one gets the parenthesis? Which one's included and which one is not? Allison?
The -2
It's not -2, -2. It's just -2 because we're only looking at the x values. So you said that gets the parentheses? Is this an open dot or a filled dot? Solid dot?
Open dot.
That's not an open dot.
Oh, it's filled dot. I wasn't looking.
So the bracket, right. The -2 gets the bracket because it starts with a filled in dot. Then the 1 doesn't really exist. It's everything up to 1. So that's going to be a parenthesis. So what does this refer to? This refers specifically to the values from -2 up to but not including 1. This function exists only within that domain. Okay? Now, for the range, the storm changes direction. The storm, here it comes from the side and moves over. For the range, it's going to come from the bottom and move up. When does the storm line touch the first player? -2. Good. Is it actually touching a player there, or is that like not really a player?
It's a player.
That's a player because it's a filled in dot, right? And I keep touching the line. I'm following the line, but I'm going straight up. The line is touching my storm line until I get to
1.
Until I get to 1. So the range and the domain actually in this problem look an awful lot alike. Is the -2 included? Yes, because it's got the dot. How about the 1?
Parenthesis. Yeah, parenthesis.
Parenthesis, that's right. Parenthesis. So not included because we have an open circle. So what I just identified is, what are the y values of this function? As I'm coming across left to right, that's your x values. If I'm coming from the bottom up, that's your y values, domain and range. Let's look at another one.
You okay?
Yeah, he's got the junk that is going around.
Strut.
It's tough to get rid of.
I think it's strut.
You know, it's something and it's no fun. Dylan, if you need to go get a drink, feel free. Okay, let's make this one a little harder. A little bit more in each direction. Let's say that I start here.
How many do you have in each direction?
You probably don't need as many as I have. I've got like 4 or 5 in each direction. Probably need at least 4 though. So let's say that this function looks like this. So the question I might ask you before we start looking at this is there a spot where the function doesn't exist?
No.
Is there a spot where the function doesn't exist?
No, there isn't.
No, I think I got a hole right there. Does
Oh, so yeah, you gotta have like another point to close it up.
Yeah, but there is no other point. So how do we deal with that? So let's look at the domain. So the storm is coming from the left to the right. When do I, yeah, okay, forget the circle. I know it comes in a circle, but I got to adapt it a little bit. Okay, when do I start touching the players?
-2.
-2, right. So x is an element that starts at -2. Is that going to be included with a bracket or parentheses? Not included. Included, bracket. Good. And I go to where? Oh, but the 0. There's a hole there at 0.
So yeah,
Is that included or not?
included.
Not included. It's an open circle. Now, but if I keep drawing across here, I start touching players again. At what number?
0.
0. Because 0 is a hole. Everything up to 0 is okay. Everything after 0 is okay too. But 0 has a hole in it. There's no point there. It's a non-point. Okay? And remember, we're only talking about the x values. So as I'm looking across this and my storm line is touching players, I'm really only considering the x values here where my pencil is at. So it goes up to 0 and falls away. It disappears. Hang on a second. And then as soon as I get past 0, it starts again. And I've got these x values because I'm touching a line here until I get to 4. Right. You have a question?
Yeah, so like, are we ever gonna like know why we don't have like, I mean, why we do have non-points?
Yeah, I can give you an example. Let me finish this up and I'll give you an example. Okay? All right. All right, so the domain, what did I use yellow before? The domain is here to here and here to here, but there's a hole in the domain. There's no value here in the domain because there's a hole there up at the top. Does that make sense? Now let's look at the range. So I have to list it in a couple of different parts. The domain goes from -2 to 0, and then there's a hole, and then 0 to 4. Now, let's look at the range. So my storm is sort of coming up from the bottom. When do I touch players?
0.
At 0. Good. Good. So y is an element. Do I include the 0 or is that a parenthesis? Bracket. Good. Now, and I keep going, when do I quit touching players? Looks like I'm touching them in 2 places. Is that okay?
No. Oh,
Yeah, that's okay. When do I quit touching them?
At 4.
Is that 4?
Yeah.
I think it's 3. Bracket or parenthesis?
Parenthesis.
And see, I don't need any other part here because it goes until it doesn't anymore. I'm touching in 2 spots, but that's okay. Now that's what I have for you in terms of notes, but I just had a great question. When would we have holes? In Boise, I think most of you guys live in Boise, right? They've rolled out those scooters, those electric scooters.
Yellow line.
Yeah, the Lime, and then there's another, there are 2 Bird, yeah, Lime and Bird scooters, right? Well, if I were to graph the rate of expense on that, it's going to look something like this.
I don't know what it is.
How much is it? Remind me.
I believe it's like $1 starting. and
Dollar
you
to
have
start.
Pay like 15 cents a minute.
I think so. It adds up. It definitely adds up.
If you want, you can like make money, like picking them up and charging them.
I've heard that. I've heard that. So let's look at this. So if I go 0 minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, I won't go very far. And this is going to be cost. It's going to start at, I'm going to put $1 here, and then it's going to be 1.15 and 1.30, 1.45, and so forth. So to get on one of these scooters, and I don't know if they're the same price for both companies or not. I'd guess they're probably pretty close, but let's say that they are. You get on one of these scooters, you put your card in, and it's going to charge you $1. Right off the get-go. It's charging you $1, and it starts the time right then. So really, my starting should probably be about $1.15, not $1, honestly. Because anything from 0 to 1 is going to be $1.15. As soon as I get to 1 mile, or 1 minute, not 1 mile, it changes. And it steps up. So if I go 0.9 of a mile, it's going to cost me $1.15. If I go anything more than 1 mile, 1 mile and 1 foot, it's going to charge me the next mile's rate until I get to the 2nd mile. and I'm going to have an open hole there because I can't charge at both places. Does that make sense? And this is exactly how taxi cabs charge and all sorts of things. But from your guys' perspective, you're probably more likely going to ride the bird scooter than the taxi cab in the near future. So yeah, there are definitely holes in graphs. So this is a really common one. Things get charged this way all the time. Okay? Good question. I'm glad you asked that.